Hey, Sponge. Yesterday, I was performing an experiment in electrical lab. There I found an interesting 8-legged resistor. I wonder what it is for.
Huh?
Yeah, it just looked like a big spider with small legs.
Oh man, it is called an integrated circuit.
Huh? What is that?
Our digital world is full of integrated circuits. It is a very important electrical device which is quite often used in most other today's electrical components.
Can you explain me something more about it?
Yeah, of course. An integrated circuit is a circuit much smaller than a discrete circuit made from independent electronic components. ICs can be made very compact, having up to several billion transistors and other electronic components in an area the size of a human fingernail.
What did you say? Trans what?
Transistor?
Yeah, what is that?
Oh god, you're so stupid. You don't even know about transistors. Okay, first I will explain you about transistors, then we will look into ICs some other day. This topic is too much fun.
This seems quite interesting.
Okay, let us start.
Yeah,
Okay, so we start through basics. Semiconductors are elements which have conductivity between conductors and insulators. Semiconductors are like insulators in their pure form but have smaller atomic band gaps. Adding dopants increases their conductive properties. Transistor. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It is composed of semiconductor material, usually with three terminals for connection to an external circuit. A voltage or current applied to one pair of the transistor terminals changes the current through the another pair. It can either allow current or prohibit current to flow. It is useful as a switch and as an amplifier. It has two types: bipolar junction transistor and field effect transistor. Bipolar junction transistor, it has three regions of doped semiconductor: base, collector and emitter. Base is thin layered and least doped. Collector is most thick and moderately doped, whereas emitter has moderate thickness and it is highly doped. There are two types of bipolar junction transistor: NPN and PNP. Now coming to the main part, the application of transistor. BJT as switch. The circuit diagram for switch configuration is as shown. When the input voltage is low, the base emitter junction is not forward biased. Therefore, the output voltage is high. When the input voltage is high, the base emitter junction is forward biased. Therefore, the output voltage is low.
Can we use this BJT as a switch to drive high power sources like bulb?
Yes, there exists a solution to this also by having some modifications in the circuit, which is called the Darlington pair. This is Darlington transistor configuration. In this, two transistors are connected to each other. Also, you should note an important thing that the base of one transistor is connected to the emitter of the another transistor. Darlington transistor configuration. Using the NPN Darlington pair as an example, the collectors of the two transistors are connected together and the emitter of transistor 1 drives the base of transistor 2. This configuration achieves beta multiplication because for a base current IB, the collector current is beta IB, where the current gain is greater than 1 or unity. But the base current IB2 is equal to the transistor 1 emitter current, IE1. as the emitter of transistor 1 is connected to the base of transistor 2. The following equations can be easily obtained by solving it. In the above equations, beta 1 and beta 2 are the gains of the individual transistors. This means that the overall current gain beta is given by the gain of the first transistor multiplied by the gain of the second transistor as the current gains of the two transistors multiply. In other words, a pair of bipolar transistors combined together to make a single Darlington transistor pair can be regarded as a single transistor with a very high value of beta and consecutively a high input resistance. Therefore, if beta 1 equals to beta 2, then we get IC equals to beta square plus 2 beta times IB. Now coming to the applications of Darlington pair, it allows for much greater gain in a circuit. As we have shown, beta equals to beta 1 into beta 2. It is easy and convenient circuit configuration as very few components are used. In case of photo Darlington pair, noise introduced is very less compared with a phototransistor with an external amplifier.
Wow, I'm feeling too knowledgeable. Oh, Spongy, you are my best friend.
Okay, we are out of time now. Next time we will discuss about integrated circuits.
Thank you. Goodbye. Have a nice day.